Welcome to 12.6. Today we're going to talk circular and periodic functions. For vocab terms today, we have unit circle, and that is a circle with a radius of 1 unit centered at the origin of a coordinate plane. A circular function are functions defined using a unit circle, mainly sine and cosine. Periodic functions are functions in which the y values repeat themselves at regular intervals. A cycle is one complete pattern of a periodic function, and then a period is the horizontal length or distance of a single cycle. So we've got our unit circle here. Okay, now the main part that we're going to be adding is this part in the top right corner. Okay, the sine or cosine of theta, sine of theta. So that tells us that any of these points, if we're looking for the cosine, we look for the x-coordinate. So if we want the cosine of 60 degrees, we take the x-coordinate of 60 degrees, which is 1/2. If we would do the same for the sine of 60 degrees, we would use the y value of square root of 3/2. So how this is going to work is you're going to be given an ordered pair that's on the unit circle. The cosine is always the first number, the sine is always the second. So the questions will look something like this. The terminal side of angle theta in standard position intersects the unit circle at the point 1/2 square root of 3/2. Find the sine and cosine of theta. Okay, so for cosine, that's always the x-coordinate. So the cosine is going to be 1/2. The sine is always the y-coordinate, so it will be square root of 3/2. That's all you have to do. X-coordinate is cosine, y-coordinate is sine. Now we've got the terminal side of angle theta in standard position intersects at the point 3/5, -4/5. So again, finding sine and cosine. Cosine, again, is our x-coordinate, so it's going to be 3/5. Sine is our y-coordinate, so we have -4/5. So the negative will come along with when we do this. So again, x is cosine, y is sine. So now we've got the point is -7/25 and -24/25. So again, to find cosine, we take the x-coordinate, -7/25. To find the sine, we take the y-coordinate, -24/25. Okay, and that's all we need to do. Cosine is x, sine is y. The last thing I want to show you is one that looks like this. It's a little bit different. Okay, we've got the point 6/10, 8/10. So cosine, just like always, we take the x-coordinate 6/10. The only thing we have to watch out for, we can simplify 6/10. That'll become 3/5. So the cosine is really 3/5. So we have to simplify our fraction if we can. Sine, again, we take the y-coordinate 8/10. That'll simplify down to 4/5. So make sure, before you just write down the fraction as it is, make sure it can be simplified. And if it can, make sure you do it. Next thing we're going to talk about is periodic functions. Okay? Periodic functions are functions that over a given amount of time, they'll come back to this original position and then start repeating itself. So for here, you'll notice that this gets repeated. So we start here and go up and down to the same spot again, and then we repeat itself over and over. Okay, so one of those is called the period of the function. Okay? And that can be many different forms. If you look here, you can start here, and the period would go back to here, so between here and here. And you'll notice that it's a straight drop down, over, and then back up. Straight drop down, over, and back up. It repeats itself. Okay? And if we took the distance here, it has a period of 2. Okay? So again, it's always repeating itself and returning to its original position. Okay, on the bottom left, you'll notice we're up at the top here, and it goes all the way to here until it gets back into its original position. So this case, the distance would be 2 pi. Okay, not necessarily need to know that off the top of your head right now, but it's good to know. Okay, and then here we could go with the bottom, would go down to here. Okay, and we'd find this distance there. Now it doesn't have to be those exact spots to find our period. Okay, if I wanted to, I could start here in this top right one, and I would go back to here. As soon as it's returning to its same spot again, and you'll notice the distance is always the same. So I could go from here to here on the bottom left one. Okay, the period will always be the same. there, and there. Okay, so it doesn't matter where you choose to start, you just have to make sure you get all the way back to the original position before finding the period. So this is just an intro to it. We'll do more in the next section, but I just wanted you to see that before we got there. The last thing we're going to talk about is a little bit of review, but it's going to be a little bit of a new information. We're going to go back to finding the exact value of a given function, okay? So we're going to go back to that big table that we had. If you remember, we had sine, cosine, tangent, cosecant, secant, and cotangent of 0, 30, 45, 60, and 90. Remember that table? You'll need that again. But now we're going to be using numbers outside of what we normally have. So now we're going to find the cosine of 480 degrees. Okay, that's not something we've been working with. We've usually been going between 0 and 360 or between 0 and negative 360. So what we do here is we're going to find our coterminal angle that is between 0 and 360 first. Okay? So in order to do that, remember, we either add or subtract 360. Well, if we're at 480, we're going to want to subtract 360 to find our coterminal angle. And that's going to be 120 degrees. So really, we're looking for the cosine of 120 degrees. Once again, to find that, we need to find the reference angle. Well, 120 degrees sits over here in quadrant 2. To find the reference angle, we take 180 minus theta. So if I do that, 180 minus my angle of 120, that's going to get me 60 degrees for a reference angle. So if I find the cosine of 60 degrees, that's going to start it out here. And the cosine of 60 degrees is 1/2. Then we have to look at the quadrant. We're in quadrant 2. So that means that our cosine is actually negative. So the cosine of 120 degrees is a negative 1/2. Well, if the cosine of 120 degrees is a negative 1/2, that tells me that the cosine of 480 degrees is also a negative 1/2. So we kind of have to do one step at the beginning, and then it's all the stuff we've done in the past, and then we go back to answer our question. So we're just introducing finding that coterminal angle first, then going what we've done in the previous lessons. We could also be given it in radians. Okay, in order to do that, we want to switch over to degrees, and I've written the formula to convert it into degrees on the top there. So to turn 11 pi over 4 into degrees, I need to multiply it by 180 over pi. And if I do that, and I type that into my calculator, I get that 11 pi over 4 is the same as 495 degrees. So I'm looking for the sine of 495. Okay, once again, I need to find my coterminal angle. So since it's 495, that's bigger than 360. I need to subtract 360 to find my coterminal angle. And that's going to get me 135 degrees. So if I can find the sine of 135, I can find the sine of 495. So from there, I find my reference angle. Well, 135 sits in quadrant 2 again, so I'm going to subtract it from 180 and get 45. So my reference is going to be the sine of 45 degrees. Sine of 45 degrees is the square root of 2 over 2 from my table. Now I use that to come back here. In quadrant 2, sine is positive, so the sine of 135 is also the square root of 2 over 2. And since I know what that is, that's going to be the same as the sine of 495. So my answer is going to be the square root of 2 over 2. So once again, we're just introducing those coterminal angles first, and then doing the same thing we did in previous lessons. Now we're given a negative radian degree measure. Cosine of negative 3 pi over 4. We start out the same way. I want this to be a degree measure. So negative 3 pi over 4 times 180 over pi. I'm going to get a degree measure of negative 135. So I'm looking for the cosine of negative 135. So for my coterminal angle, since it's a negative, I need to add 360 to it to get it to be positive. So negative 135 plus 360 should get me a 225 degree angle. So I'm looking for the cosine of 225. Okay, I find my reference angle. 225 sits in the third quadrant, so I would take my angle minus 180 to find my reference. So it's a 45 degree angle. So if I look for the cosine of 45 degrees on my table, that's where I start. Okay, it's the square root of 2 over 2. Then I work backwards. Okay, in quadrant 3, where my angle is at, cosine is negative, so the cosine of 225 is negative square root of 2 over 2. Which tells me that it's the same as my cosine over here. So my answer would be negative square root of 2 over 2 for the cosine of negative 135 degrees, or negative 3 pi over 4. Go ahead and pause the video, do this last one on your own, and then hit play and see how you did. So starting off with 420 degrees, you should have gotten that the coterminal angle is 60 degrees, so we're looking for the sine of 60. The reference angle for a 60 degree angle is just 60 degrees, so we're looking for the sine of 60, which on our table is square root of 3 over 2, and it's in quadrant 1. Sine is positive in quadrant 1, so the sine of 60 is square root of 3 over 2, which means that the sine of 420 is equal to that, which is the square root of 3 over 2. So once again, the only thing new we're adding is adding or subtracting 360 until we get a number between 0 and 360, and then we go back to the reference angle and the quadrant, figuring out what the exact value is and whether it's positive or negative, and then we can work our way back.